Hi, my name is Aaron, and I'm going to talk about our circuit that we built for our farming agribot. So, from the circuit diagram, we can see we used the 5-volt input, which comes out of the Arduino, into a Wheatstone bridge. So, from the Wheatstone bridge, we have our thermistor, which is our RTH. We have R2, which is the maximum resistance of our thermistor, which is 804 kilo ohms, and we found the best value for R3 and R4 to be 36 kilo ohms. In order for the bridge to be balanced, R3 and R4 need to be equal. So we used 1 mega ohms resistors coming out of the Wheatstone bridge into the LM324, which we then put the two voltages together to create a single output voltage, which can be then read by the Arduino, which we will rescale in order to get our temperature value. I'm now going to show you the circuit that we've built. In order to build a circuit, we needed to create an 805 kilo ohm resistor. So we made the 805 kilo ohm resistor by using 2 mega ohms in series with 1.3 mega ohms, which is then parallel with an 18k resistor. This gives us a total resistance of 805, which is very close to the 804 kilo ohms produced by the thermistor, which we can see here. We have 1 mega ohm resistors joining the Wheatstone bridge to the op amp, and 1 mega going out from the op amp. Our op amp is here by the little black chip, and over here we have our 36 kilo ohm resistors for R3 and R4. We then have our power supply here, and we have our Arduino linked up to pin 1 on the op amp. It also enters into the circuit here, which gives the 5 volts needed to power the circuit, and we also have the Arduino connected to ground to complete the circuit. As we can see, we have our thermistor and our glass of water, which is roughly about 0 to 4 degrees. Because the ice been sitting for a few minutes, we have 2.48. So if we go up to our Excel sheet, we can see that we get a value for 2.48 to be between minus 0.5 degrees and 4 degrees. So if we take the thermistor out of the water and let it set up to room temperature, we can see it slowly begin to crawl up as the temperature changes from the water to the room temperature. So I'm just going to hold the thermistor in order to speed up the process a bit. So as we can see, it's a little bit later now, so the room is slightly colder than previous. So when we were in conversation with Sebastian, we had 3.5 volts, whereas now it's a little bit colder, so we have 3.43. So if we go back to our graph on the right hand side, we can see 3.43 is approximately between 17 to 22 degrees. So then what we can do is we can up the temperature again. So by holding the thermistor in my hand, we can get it up to 3.8 volts. So when we look at their Excel sheet again, we can see that 3.8 goes up to above 26 degrees. So from the temperature ranges that our farming machinery will work, it rarely will be working below 0 degrees, and we were told that it wasn't really going to be working above 20 degrees. So from the results we've proven that our thermistor works reasonably well between the temperature gauges shown that the mechanical engineers require. Thank you.